Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on pressure. If you need any extra help on this topic, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 385, there's a dedicated video tutorial there on pressure. Alternatively, you can scan the QR code on the front of this booklet. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so question number one. Question number one says, find the pressure exerted by a force of 8,000 newtons on an area of 25 meters squared. And we've been asked to give our answer in newtons per meter squared. Okay, so I'm going to write down the formula for pressure to begin with. Pressure is equal to the force divided by the area. So if you want to find the pressure exerted by an object, if you divide the force by the area, that will tell you the pressure. Let's rearrange this, so let's get the versions of this formula. So if you multiply both sides by A to get rid of the A on the denominator here, you get the area times the pressure is equal to the force. So if you want to find the force, you do the area times the pressure. And finally, so we know what pressure is. Pressure is equal to force divided by area. We know that the force is equal to pressure times area, or area times pressure. And if we wanted to find the area, we would divide both sides by the pressure. So the area is equal to the force divided by the pressure. So pressure is equal to force divided by area. Force is equal to area times pressure, and area is equal to the force divided by the pressure. So those three will be really useful whenever answering these questions. Okay, so the question said, find the pressure exerted by a force of 8,000 newtons on an area of 25 meters squared. So we want to find the pressure. So the pressure is equal to the force, which is 8,000 newtons, divided by the area, which is 25. And if we do 8,000 divided by 25, that'll tell us the pressure. So the pressure will be equal to 8,000 divided by 25. And it's a non-calculator question, so I'm just doing the bus shelter method here. How many 25 is going to 8? 0. Remainder 8. How many 25 is going to 80? That'll be 3. That's 75, so it's 3. Remainder 5. How many 25 is going to 50? That's 2. And how many 25 is going to 0? That's 0. So that's equal to 320. So the pressure will be equal to 320. And then if we check our units here, the pressure was in newtons, so that'll be newtons per, and then we're dividing by the area, which was in meters squared. So that means that our pressure is equal to 320 newtons per meter squared, and that's the units we've been asked to give our answer in. So the answer is 320, and that's it. So to find the pressure exerted by a force of 8,000 newtons over an area of 25 meters squared, we just divided the force, which is 8,000, by the area, which is 25. That gives us 320. Now, another way to do this question is, rather than learning the pressure is equal to force divided by area, you can actually use your common sense. If it's 8,000 newtons over an area of 25 meters squared, if you want to find the pressure, that would be how many newtons for 1 meter squared. So you could just divide that by 25. Okay, let's look at our next question, question number 2. Okay, so question number 2. Question number 2 says a crate exerts a force of 120 newtons on a table, and the pressure on the table is 15 newtons for each meter squared. And the question says, calculate the area of the crate that's in contact with the table and to include suitable units. Okay, so in this question, we can use two different approaches. One approach is to use common sense. It's 15 newtons for every single meter squared. So if we divide the total force, which is 120 by 15, that's equal to 8. So that means it must be 8 meters squared, or 8 square meters, because each one of their square meters is a force of 15 newtons. So that would give us a grand total of 120. Or another way is to use the formula that the area is equal to the force divided by the pressure. So that means the force is 120. The pressure is equal to 15, and if we do 120 divided by 15, so 120 divided by 15, so let's count up in 15s, 15, 30, 45, 60, 75, 90, 105, 120, so that's 1, 2, 3, 4, 5, 6, 7, 8, so that means the answer would be 8. And then let's just check our units. We had here, the force was in newtons. The pressure was newtons per meter squared. When we divide that means that our answer would be in meters squared. So that's 8 meters squared. And that's it. Okay, let's take our next question, question number 3. Okay, so question number 3 says a box is placed on the floor, and the area of the box in contact with the floor is 2.4 meters squared, or 2.4 square meters. So the area of the base of the box is 2.4 square meters. And the pressure exerted on the floor is 16 newtons per meter squared. So that means for each of the meters squared, or each of the square meters, there's a force of 16 newtons. So that's the pressure, 16 newtons per meter squared, or per square meter. And the question says work out the force exerted by the box on the floor. So we know the 16 newtons for 1 square meter. So we want to find out how many newtons it'd be for 2.4 square meters. So one approach is to use our common sense and to take the 16 and times by 2.4. And that tells us how many newtons force it'd be altogether exerted by the box on the floor. Or another way is to learn the formula that the force is equal to the area times the pressure. So that'll be the area, which is 2.4, multiplied by the pressure, which is 16. And on our calculator, if we do 2.4 times 16, that's equal to 38.4. And let's just check our units here. We had meters squared, we're timesing it by newtons per meter squared, so that'll be newtons. So that's newtons, and that's it. So 38.4 newtons. And that's the total force exerted by the box on the floor. So we just times the area by the pressure. Okay, let's look at our next question, question number 4. Okay, so question number 4. Question number 4 says an object is placed on a table and it exerts a force of 22 newtons on the table. So that's the total force exerted by this object on the table. And the pressure on the table is 500 newtons per meter squared. So if there was 1 meter squared, if that was the total area, the force would be 500 newtons. So because the total force is only 22 newtons, you know the area is going to be much smaller than 1 square meter. And the question says calculate the area of the crate that is in contact with the table and include suitable units. And we want to calculate the area of the crate that's in contact with the table and to include suitable units. So there's a few different approaches. One way is to use the formula that the area is equal to the force divided by the pressure. The force in this case is 22. And we're dividing that by the pressure, which is equal to 500. And if we do 22 divided by 500, so 22 divided by 500, that's equal to 0.044. And let's just check our units with newtons, and newtons per meter squared, so that'll be meters squared, so 0.044 meters squared. So we've been asked to calculate the area of the crate that's in contact with the table. One answer could be 0.044 meters squared. That's a suitable answer. Another option is actually change that from meters squared into centimeters squared. Now to change from meters squared into centimeters squared, you don't just times by 100, you times by 100 and by 100 again. Because it's meters squared, you need to times both the, for instance, it's a rectangle, the length and the width, each by 100. So to change from meters squared into centimeters squared, you times by 10,000, which is the same as times by 100. And by 100 again. So if we times this by 100, so times by 100, and then times by 100 again, we get that's equal to 440. So 440 centimeters squared. So we could give our answers either one of those two options, 0.044 meters squared or 440 centimeters squared. And just remember to change from meters squared into centimeters squared, you times by 100 and by 100 again. Okay, so that's one way to do our question, is to learn the formula. The area is equal to the force divided by the pressure. So what I tend to do, as I said earlier on in question 1, I learn the pressure is force divided by area, and I rearrange it, and then I've got this version. Another approach is to use common sense, that each meter squared, the force would be 500 newtons. So 1 meter squared, the force would be 500 newtons. So if we know the total force is actually 22 newtons, we can then find the area by thinking, well, to get from 500 to 22, we would divide by 500 and times by 22. So if we take the 1 and divide it by 500 and then times by 22, that will tell us the area. So if we take 1 and divide it by 500 and times by 22, that's also equal to 0.044 meters squared. So either one of those approaches is totally fine to learn the formula, or to just use common sense. Well, 1 meter squared, the force is 500 newtons. You could find what 1 newton would be in terms of the area by dividing by 500, and that would tell us that was equal to, and that's equal to 0.002 meters squared. And then for 22 newtons, you times by 22, and that would be 0.044 meters squared. So just using that approach. And that's it. Okay, let's look at our next question, question number 5. Okay, let's look at our next question, question number 5. So question number 5 says, find the pressure exerted by a force of 240 newtons on an area of 30 centimeters squared. And we need to take for our answer in newtons per meter squared. Now, one thing I noticed about this question is the fact that the area is in centimeters squared and the answer is in newtons per meter squared. So what I'm going to do to begin with is I'm going to change the centimeters squared in the question to meters squared. So to change from centimeters squared into meters squared, we divide by 100 and by 100 again. So we're going to take the 30 and we're going to divide it by 100 and 100 again. So that's actually dividing it by 10,000. So you can just do it in one go by dividing by 10,000. Or you could divide by 100 to get 0.3 and divide by 100 again. So 0.3 divided by 100, which would be equal to 0.003. So that's the area. So that means the area would be 0.003 meters squared. So what I've done there is I've just changed the area from centimeters squared into meters squared. Now we've been asked to find the pressure. The pressure is equal to the force divided by the area. So here the force is 240 newtons and the area would be 0.003 meters squared. So we're going to do 240 divided by 0.003 and see what we get. So when we do 240 divided by 0.003, that's equal to 80,000. That's equal to 80,000. So that means that'll be 80,000 newtons per meter squared. And that's it. So in that question, we're asked to find the pressure exerted by a force of 240 newtons on an area of 30 centimeters squared. So what I done was I changed the 30 centimeters squared into meters squared by dividing by 100 and by 100 again, or just dividing by 10,000. That's equal to 0.003 meters. And then to find the pressure, we done the force, 240 divided by the area, 0.003, and we get that's equal to 80,000. So the pressure is 80,000 newtons per meter squared. And that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6. Question number 6 says a cuboid and a cube are placed on the floor. The cuboid has got a weight of 60 newtons and the cube has a weight of 40 newtons. So that's the force exerted by the cuboid and the cube on the ground, 60 newtons and 40 newtons. And the question says which exerts a greater pressure on the ground, and we must show our working. So let's find the pressure for each of them. So the pressure is equal to the force divided by the area. So the force here is 60 newtons and we need to divide by the area. So what I'm going to do is I'm going to find the area of the base of the cuboid, because if they're placed on the floor, the area would be the area of the cuboid that's in contact with the floor. So that's going to be the base. So the area of the base would be 8 times 3. So 8 times 3 is equal to 24 centimeters squared. So we could actually use that. The area of the base is 24 centimeters squared. And we could actually then work out the pressure by doing the force, 60, divided by the area, 24. And remember that our answer will be in newtons per centimeter squared. And that'd be totally fine. So we could do that. Or we could actually change this into meters squared. So instead of using 24 centimeters squared, we could divide it by 100 and by 100 again to get it into meters squared. And if we did that, that'd be, if we divided it by 100, that'd be 0.24, and divided by 100 again, that'd be 0.0024 meters squared. So we could use either one of these two for the area, just making sure we're using the same units for both of the areas, either centimeters squared or meters squared for both of them. So we're going to divide the weight, the force, 60, by the area of the base. So we could use 24 or 0.0024 meters squared. I'm just going to use 24 in this question. So 60 divided by 24, 60 divided by 24 is equal to 2.5. So 2.5 newtons per, and because we're dealing with centimeters squared, that'll be centimeters squared. That means we've worked out the pressure to be 2.5 newtons per centimeter squared. If you had used this version here of the area at the base of 0.0024 meters squared, we'd have 60, the force, divided by the area, 0.0024, and then that would be equal to, and that'd be equal to 25,000, so 25,000 newtons per, and because we're dealing with meters squared this time, it would be meters squared. So you could have worked out either one of these ones in terms of the pressure for the cuboid. Okay, now just do one of them, you don't need to do both. Okay, then with the cube here, we're going to do the same thing. So let's find the pressure. So the pressure would be equal to the force. So the force for this one will be 40 divided by the area. So the area of the base, so the area of the cube that's in contact with the floor would be the area of the base. So that'll be 4 times 4, which is equal to 16 centimeters squared. Or you could change that into meters squared and divide that by 100 and by 100 again. So it'll be 0.0016 meters squared. So what we're going to now do is divide the force, the 40, by the area. So let's do 16, and that would be equal to 2.5 newtons per centimeter squared. And if you'd use this one, you would have got 40 divided by 0.0016, and that'll be equal to 25,000 newtons per centimeter squared. And just to explain why these differ, this one is saying that every single centimeter squared, so think of a little centimeter square, if you draw that, the force exerted through that 1 centimeter squared would be 2.5 newtons. So the pressure is 2.5 newtons for every single one of the centimeters squared. This one's obviously much bigger because this time we're dealing with meters squared, just use that the meter squared. And so here, for every single meter squared, the force is 25,000 newtons. And obviously a meter squared is much bigger, it's 10,000 times bigger, so that's why the answer is 10,000 times bigger. Now the question says which one exerts a greater pressure on the ground? And the answer is they exert the same pressure. The cuboid exerts a pressure of 25,000 newtons per meter squared, and so does the cube, and that's it. Okay, let's look at our next question, question number 7. Okay, let's look at our next question, question number 7. So question number 7 says a television is placed on a table and the area of the television that's in contact with the table is 750 centimeters squared. and the pressure on the table is 1,760 newtons per metre squared. And we've been asked to work out the force exerted by the television on the table. So we want to find the force. So remember, the force is equal to the area times the pressure. So force is equal to area times pressure. And just remember, if you forget that you can write down that the pressure is equal to the force divided by the area, and then you can rearrange this. So you can multiply both sides by A, and you get that the force is equal to the area times the pressure. Okay, so we've got that the force is equal to the area multiplied by the pressure. Now, one thing to notice here is that the pressure is in newtons per metre squared, and the area is in centimetres squared. So what we're going to do is we're going to change the centimetre squareds into metre squareds, just so that we've got the same units in terms of newtons per metre squared and the area in metre squared as well. So we're going to change this into metre squared. So to change from centimetre squared into metre squared, you divide by 10,000. So we divide by 100 and by 100 again. So we've got a calculator here. If we take our 750 and we divide that by 10,000, or by 100 and 100 again, that's equal to 0.075 metres squared. So that's the area of the television that's in contact with the table. Okay, so now we've got the force is equal to the area, 0.075, multiplied by the pressure, 1,760, and we get that's equal to 132. So that means that the force is 132 newtons, and that's it. Okay, let's look at our next question, question number 8. Okay, so question number 8 says a cuboid trunk, so it's a cuboid trunk, so that's quite important here in this question, it's a cuboid, is placed on a table. The trunk exerts a pressure of 150 newtons per metre squared on the table, and the trunk exerts a force of 900 newtons on the table. And we're told the trunk has got a width of 1.5 metres, and the trunk has a height of 0.8 metres from the table. And the question says work out the volume of the trunk. So to work out the volume of the trunk, because it's a cuboid, the volume is equal to the length times the width times the height. Now here we're told that the trunk has a width of 1.5 metres and a height of 0.8 metres. So really we need to find the length of the trunk, so the length of the trunk. Or actually in this question, because the trunk's placed on the table, remember we can find the area because we know the force and we know the pressure, and the area is equal to force divided by pressure. So if we divide the force by the pressure, we can find the area, and that would tell us the area of the trunk that's in contact with the table. And because it's a cuboid, that'll be the area of the base. And then once we find the area of the base, we can just times it by the height of the trunk, because the area of the base will be the length times the width. And then if you times it by the height, that'll give you the volume. So let's find the area of the trunk that's in contact with the table. So the area is equal to the force, 900, divided by the pressure, 150. And if we do 900 divided by 150, that's equal to 6 metres squared. So that means the area of the trunk that's in contact with the table is 6 metres squared. Now here, we could divide that by 1.5 to find the length of the trunk and then do the length times the width times the height. So you could do 6 divided by 1.5. That's equal to 4. So it means the length of the trunk is 4 meters, the width is 1.5 and the height is 0.6. And then you could times the 4, the 1.5 and the 0.6 together. But keep in mind that 4 times 1.5 is 6 meters anyway. So now we just really need to do 6 times 0.8. You could just do the area of the base times the height. So the volume will be equal to the area of the base. So that's going to be 6 multiplied by the height of the trunk, which is 0.8, and that's equal to 4.8 meters cubed. So the volume of the trunk is 4.8 meters cubed, and that's it. And just to mention there, remember that you can do 6 divided by 1.5 to get 4, and then you know that the length's 4, the width is 1.5, and the height is 0.8, and then if you times them all together, you get a volume of 4.8 meters cubed, and that's it. Okay, let's look at our next question, question number 9. Okay, let's look at our next question, question number 9. So question number 9 says a cylinder is placed vertically on the ground, and the cylinder's got a weight of 85 newtons, so that's the force, 85 newtons, and it's got a radius of 2 centimeters, and we've been asked to work out on the pressure on the ground in newtons per centimeter squared. Okay, so we've got the force, we've got the radius of the cylinder, and it's placed upright on the ground. So if you think of So if we imagine the cylinder, it's placed upright on the ground like so. It's a little sketch here, not necessarily the best, but it's a little sketch. And it's placed on the ground, so there's the ground and it's placed on the ground. The area of the cylinder that's in contact with the ground will be the base of the cylinder. That base of the cylinder, that circle on the base, will be in contact with the ground. So we need to find the area of the circle. So we need to find the area of that circle. Now in terms of the area of that circle, the radius is 2 centimeters. So the area will be equal to pi r squared. So pi times the radius squared. So the area will be equal to pi times 2 squared. And 2 squared is 4, so we get the area of the base will be equal to 4 pi, or as a decimal number, 4 times pi is equal to 12.5663761 centimeters squared. So that's the area of the circle. So that's the area of the base of the cylinder. So now we can work out the pressure because the pressure is equal to the force divided by the area. So that means that the force is 85 newtons. And we're going to divide that by 12.566 and so on, or 4 pi. And when we do that, we get an answer of, that's equal to 6.764, and that's the 3 decimal places. And that's going to be in newtons per centimetre squared because we're dividing the newtons by the centimetres squared. So it's going to be newtons per centimetre squared. And that's it. So 6.764 newtons per centimetre squared. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So question number 10 says a lead rod is placed on a table. So we've got this lead rod, and the rod is a cylinder, and it's got a diameter of 8 centimetres, and it's got a height of 20 centimetres. And the force exerted on the table is 111.72 newtons. And we've been asked to work out the pressure in newtons per metre squared. Okay, so we want to find the pressure, so the pressure is equal to the force divided by the area. Well, we know the force is going to be equal to 111.72, but we need to find the area. Now, one thing to notice here, we want to find the pressure in newtons per metre squared. So when we find the area here, I'm going to want to find it in metres squared rather than centimetres squared. So let's find the area of the base of the cylinder because that's what's in contact with the table. So in terms of the base of the cylinder, that's going to be a circle. So we're going to use pi r squared, so pi times the radius, which is 4 squared. And let's do pi times 4 squared and see what we get. So it's pi times 16, and that's equal to 50.26548 and so on centimetres squared. So that's the area of the base of the cylinder. Now we want to find the area in metres squared here, so I'm going to convert this from centimetres squared into metres squared. So we're going to divide by 10,000 because we're dividing by 100 and by 100 again. So when we divide by 10,000, we get an answer of 0.0050265 and so on metres squared. So we're going to divide by the area in metres squared, which is 0.005065 and so on. And I've left that my calculator display, so now I just need to type in 111.72 divided by answer, and that's equal to 22,225.9878 newtons per metre squared. And that's it. So the answer is 22,225.99 to 2 decimal places. And that's it. Okay, let's look at our next question, question number 11. So question number 11 says the pressure of a tyre is 32 pounds per square inch. And given that 1 pound is 0.4536 kilograms and 1 inch is 2.54 centimetres, we've been asked to work out the pressure in grams per centimetre squared or per square centimetre. So we need to change the units for the pressure from pounds per square inch to grams per square centimetre. Okay, so here we've got 34 pounds per inch squared. So that's the units at the minute, 34 pounds per square inch. Okay, so my first step is we want it to get to be grams per centimetre squared, so or square centimetre. So let's change from pounds to kilograms because we can change from pounds to kilograms because every pound is 0.4536 kilograms. So to change from pounds to kilograms, we multiply by this. So we just need to multiply. So we're going to multiply by 0.4536, and that would give us 34 multiplied by 0.4536 is equal to 15.4224, and now instead of pounds we're in kilograms, so kilograms per square inch. Okay, so we've now got in kilograms per square inch. Now we want the answer to be in grams per square centimetre, so let's now change from kilograms to grams. So the change from kilograms to grams we multiply by 1,000. So let's multiply by 1,000, and that'll be 15,422.4 grams per square inch. So we're almost there. We've got grams and we've got grams, but we want that per square centimetre rather than per square inch. So we need to change from square inches to square centimetres. So we know that 1 inch is 2.54 centimetres. Now we want to find out what 1 square inch is. So a square inch would be, if we had a square, it would be 1 inch by 1 inch, so 1 inch by 1 inch. So if we draw the same square, and this time instead of using inches we use centimetres, it would be 2.54 centimetres by 2.54 centimetres. So the area of this one would be 1 square inch because it's 1 inch times 1 inch. Here, if we want to find the area of this one, we'd do 2.54 times 2.54. So 2.54 multiplied by 2.54 is equal to 6.4516 centimeters squared. So it means that 1 square inch is 6.4516 centimeters squared. So this is grams per square inch, but we want it to be grams per square centimeter, so we need to divide by 6.4516. So let's do that. So let's divide by 6.4516. And when we divide 15,422.4 by 6.4516, we get an answer of 2,390.476781 grams per centimeter squared, or per square centimeter, and that's it. So the pressure in grams per square centimeter would be 2,390.476781, and that's it. And I'm going to round that to 2 decimal places. That'll be 2,390.48 grams per centimeter squared. Okay, let's look at our next question, question number 12. Okay, so question number 12 is very similar to question number 11, but this time we're doing it the other way around. We're going from grams per centimetre squared to pounds per square inch. So we know the pressure of the football is 500 grams per square centimetre squared. And we want to change it to be pounds per square inch. So the first thing I'm going to do is I'm going to change the centimetres squared into inches squared. So thinking back to our previous question, 1 inch by 1 inch would be the same as 2.54 centimeters by 2.54 centimeters. So 1 square inch would be equal to 6.4516 centimeters squared. So this is the pressure, 500 grams per centimeter squared. But if we want to change the square inches, that's going to be a bigger area. It's actually going to be, instead of 1 centimeter squared, it's going to be 6.4516 centimeters squared. So let's multiply by 6.4516. So that'll tell us how many grams it would be for a square inch rather than a square centimeter. And when we do 500 multiplied by 6.4516, that's equal to 3,225.8 grams per square inch. Okay, so we've now got that in grams per square inch, but we now obviously want to get the answer in pounds per square inch. We need to change from grams to pounds. So I'm going to change from grams to kilograms to begin with, because if we change this from grams to kilograms, we can then change from kilograms to pounds. So let's divide this by 1,000. So let's divide by 1,000. So divide by 1,000. And if you divide 3,225.8 by 1,000, we get 3.2258 kilograms per inch squared, per square inch. Okay, so we've now got it in kilograms per square inch, but we want it in pounds per square inch. So to change from kilograms into pounds, we're going to divide by 0.4536, because each pound is 0.4536 kilograms. So we need to see how many of these go into 3.2258 kilograms to see how many pounds it would be. So let's divide by, so let's divide, a little arrow there, divide by 0.4536. And when we divide that by 0.4536, we get an answer of 7.111552028 pounds per square inch. And that's it. And I'm going to round that, it to 4 decimal places. That'll be 7.1116 pounds per square inch. So pounds per square inch, another way right now is PSI, pounds per square inch, or here I've done LB/inch squared, okay? And that's it. We've looked at how to change from grams per square inch to pounds per square inch. Okay, let's look at our next question, question number 13. Okay, let's look at our next question, question number 13. So question number 13 says a square-based pyramid with a perpendicular height of 15 centimeters is placed on a table. So that means obviously then the base will be a square because it's a square-based pyramid. So that means that in contact with that table will be that square. The weight of the pyramid is 70.56 newtons. So that's the force. And we're told that the pyramid exerts a pressure of 4,900 newtons per meter squared on the table. And we've been asked to work out the volume of the square-based pyramid. Okay, so let's start off by finding the area of the base of the pyramid, because that's going to be the area that's in contact with the table. So area is equal to force divided by pressure. So if we take the force, which is 70.56, and divide that by the pressure, which is 4,900, that'll tell us the area of the base of the square-based pyramid. So it will tell us the area that's in contact with the table. So 70.56 divided by 4,900 is equal to 0.0144. And because the pressure is in newtons per meter squared, we're dealing with meters squared here, or square meters. So let's actually change this to centimeters squared. So I want to change from meters squared to centimeters squared. So we times by 10,000, we times by 100 and by 100 again. So if we do 0.0144 multiplied by 10,000, that's equal to 144. So that means the area of the base of the square base pyramid is equal to 144 centimeters squared. So that actually means it's a 12 by 12 square, because 12 times 12 is 144, remember it's a square. So we've got the square base pyramid. We know the area of the base is 144 centimeters squared. We know the perpendicular height of the pyramid is 15 centimeters. So we just need to find the volume. So the volume of a pyramid is a third the area of the base times the height. So that's going to be a third times the area of the base, which is 144, times the height, and the height is 15. So if we do a third multiplied by 144 multiplied by 15, that's equal to 720 centimeters cubed, and that's the volume of the square base pyramid, 720 centimeters cubed. So just to recap on that question, we divided the force by the pressure to find the area in contact with the table. That's the area of the square base pyramid, the area of the base of the square base pyramid, and that would be equal to 0.0144 meters squared. We changed that 0.0144 meters squared into centimeters squared by times it by 10,000. That's times it by 100 and 100 again. Then we use the formula to find the volume of the square base pyramid, which is a third the area of the base times the height. The area of the base is 144 and the height was 15, so we've done a third times 144 times 15, and that's 720 centimeters cubed, and that's it. Okay, let's look at our next question, question number 14. Okay, so question number 14, there's a lot of information in this question. We're told the containers A and B are placed on a shelf. So we've got these two containers placed on a shelf, and both containers are cylinders. So that means the base of both of these shapes will be circles. We've got some dimensions of A. The height of A is 20 centimeters. And in terms of B, container B, we know its height is 12 centimeters and the diameter of the base is 16 centimeters. And we're told the pressure on the shelf from container B, this container, is 3 newtons per centimetre squared. So every single centimetre squared applies a force of 3 newtons. And then we're told that the ratio of volume A to volume B is 5 to 4. So if we know the volume of this shape, perhaps we can then find the volume of this one. And then we're told the ratio of the force exerted by A to the force exerted by B is 10 to 7. And we're asked to find out the pressure on the shelf due to container A. So we want to find out the pressure that container A exerts on the shelf. Okay, so we want to find the pressure exerted on the shelf by container A. So what I'm going to do to begin with is I want to find out actually the area of the base of container A, because if we can work out the area of the base of container A, that'll be the area in the formula, that the pressure is equal to the force divided by the area. Okay, so to find the area of the base of A, what I'm going to do is I'm going to find the volume of B. So I'm going to find the volume of that container, and then I'm going to use this ratio to find the volume of A, and then we'll divide by the height of A, and that'll tell you the area of the base, the area of the cross section of that cylinder. Okay, so let's start off with container B. So in terms of B, it's volume. The volume would be pi multiplied by, remember the volume of a cylinder is pi r squared times the height. So that's going to be pi times r squared, so pi r squared times the height, that's going to be the volume. So the volume would be pi times the radius of the base will be 8 centimeters, 8 squared, multiplied by the height of the container, which is 12. So let's work out what that would be. So if we do pi multiplied by 8 squared multiplied by 12, that's equal to 768 pi centimeters cubed, or as a decimal number, that would be equal to 2,412.74315 centimeters cubed. So we've got the volume of container B, and I'm just going to keep it in terms of pi at the minute. It's 768 pi centimeters cubed. Now we can then find out the volume of container A, because we're told the ratio of the volume of A to the volume of B is 5 to 4. So if we divide this volume by 4 and then times it by 5, we can find the volume for A. So in terms of container A, we're going to take the volume of B, which is 768 pi, and we're going to divide it by 4, its number in the ratio, and that's equal to 192 pi. And then we're going to take the 192 pi and we're going to times it by 5. And that's equal to 960 pi centimeters cubed. So we've now worked out the volume of container A. So this is fantastic. Now we know the volume of container A. Remember, to find the volume of a cylinder, you find the area of the circle and times it by the height. So if we divide by the height, we'll find the area of the circle. So let's do that. So let's take the 960 pi and divide that by 20. And that's equal to 48 pi centimeters squared. So that's the area of the base. The area of the base is 48 pi centimeters squared. So that's fantastic. We're getting there because we've been asked to find the pressure on the shelf due to container A. So the pressure that A exerts on the shelf. So that's going to be the pressure is equal to the force divided by the area. And we know the area now is 48 pi centimeters squared. Okay, now what we need to do is we need to find the force. So to find the force, what we're going to do is we're going to go back to container B. And in terms of container B, we know the pressure. The pressure exerted on the shelf from container B is 3 newtons per centimeter squared. So what I'm going to do is I'm going to find the area of the base of B. And then I'm going to use the area and the pressure to find the force. And we can find the force that B exerts on the shelf. And then we're going to use this ratio, the fact that we know the ratio to the force exerted by A to the force exerted by B is 10 to 7 to then find the force exerted by A. So it's quite a complicated question, this one. We've got quite a lot of steps. Okay, so let's start off by finding the force exerted by B on the shelf. So let's go down and do that. Okay, so in terms of B, we want to find the force. So the force is equal to the pressure times the area. So that's going to be the pressure, that's 3, multiplied by the area. Well, here we've got a circle, and the area of the circle will be pi r squared, so pi times the radius, which is 8 squared. 8 squared is 64, so that's 64 pi centimeters squared. We could work in terms of decimals here, but I'm just going to keep it exact at 64 pi. So the area of the base of this cylinder is 64 pi. So we're going to do 3, the pressure, multiplied by the area, which is 64 pi, and that'll give us the force exerted by B on the shelf. And when we do that, we do 3 times 64 pi is equal to 192 pi newtons, or as a decimal number, if you wanted a decimal, 603.1857895 newtons. So that's the force exerted by B on the shelf. Now we're going to go to this ratio here, because we know the force exerted by B, and we know the ratio of the force exerted by A to the force exerted by B is 10 to 7. If we divide the force exerted by B by 7 and then times it by 10, we'll find the force exerted by A. So let's take the 192 pi and divide that by 7 and see what that's equal to. And I've got that's equal to 86.169 and so on. And then we're going to times it by 10, the A's number in the ratio. So 86.169 and so on times by 10 is equal to 861.69 and so on newtons. So that's fantastic. We now know the force. The force exerted by A is 861.6939 and so on newtons. And that's fantastic because now we can find the pressure, because pressure is the force divided by the area. So let's do that. So the pressure is equal to the force, which is 861.6939 and so on. And we're going to divide that by the area. The area was 48 pi, and that's equal to 40 over 7, or 47ths, or as a decimal number, that's equal to 5.71428 and so on. And I'm just going to round that to 3 decimal places. That'll be 5.714 newtons per centimetre squared. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on pressure. If you need an extra help on pressure, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 385, there's a dedicated video tutorial there on pressure. Alternatively, you can scan the QR code on the front of this booklet. I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.